We will now tackle section number 5. It is a continuation of section number 4. We will now cover a couple of key exercises to determine if the bias calculated is significant or not for our measured tolerance. So let's consider that Hudson currently has a measurement system for part lengths. After measuring a 5-inch gauge block for 10 measurements, we got the following results. Is the system considered to be biased? Should we use this measurement system for length measurements of 2 inches plus minus 0.5 inches? So what we're going to do right now is we're going to copy our information and we're going to paste it over into Minitab. So I'm going to open up a new worksheet and I'll paste my information. There we go. We will now do stat basics one sample t-test and we'll do a hypothesis test for 5 inches. Now from here, I can simply copy my output. So I'm going to copy as picture. And now we can review. Based on the p-value, since my p-value is above 0.05, I know that the bias is not significant. So there is no significant bias. P-value above 0.05. Okay. Now let's say that the bias had been significant. Had the bias being significant, we would consider a negative bias of 0.00, around 15-ish. Let's see the difference. Let's do 5 inches minus 4.9965, 0.0035. There we go. Now, is this significant? Well, we would simply do our formula. So here, I can add the formula here and we can change it. The system bias, 0.0035, and the process tolerance, which in this scenario, the process tolerance is plus minus 0.5 inches. So process tolerance, 0.05. Ultimately, this calculation would lead us with 0.0035 divided by 0.05 multiplied by 100, that is 7%. So 7% is less or equal to 15%. System is usable. Okay. Now let's look at exercise number 9. You can pause the video at any point to try and do it on yourself. So another one of Hudson's measurement systems has been tested using a 4-inch gauge block. The results are shown below. Is the system considered to be biased? Would you recommend a system for measuring parts with a tolerance of 10 inches plus minus 0.005? So we're going to copy our information again, and we're simply going to paste it over into a brand new Minitab sheet. So I'm going to copy and paste here. Stat basic, one sample t-test, and a hypothesized mean of 4. We can now review our data, copy as picture, can paste it here, and we do the same thing, copy as picture, and we paste it here. Based on our p-value being above 0.05, we know that the bias is not significant. So the bias is not significant, since the p-value is above 0.05. If the bias had been significant, it would have reported parts as being around 0.0, let's see, 4 minus 3.993, 0.007. Smaller than they are. Question time. Is this bias significant? So my tolerance is plus minus 0.005, and my system is reporting parts as being 0.007 smaller than they are. Evidently, this bias is actually going to be significant. It is even bigger than my tolerance. So 0.007 divided by 0.005, that gives me 1.4. 1.4 in percentage is actually 140%. So system is not usable. The bias is too big compared to the overall tolerance. Now you might ask yourself, well, p-value says that bias is not significant, but when I look at the low-level data against my tolerance, it does look highly significant. So what should I do, right? And remember, this is just one of the many tools that we're going to cover during MSA validation. Okay, so the first step is just making sure the system is not improperly calibrated. However, if you notice something like this, most likely the future tests will also fail. So don't worry about it. Okay, once we calculate gauge R&R crossed and nested, issues like this will always come up, and we'll be able to tell whether the system is usable or not. So overall, the first rule that I want all students to be aware of is system bias divided by the process tolerance must be less than or equal to 15%. But this is not going to be the only rule. We will cover future rules in the next lesson.